Hello everyone. Last class we discussed about the mirror formula and its sign convention. Today we're going to discuss about the lens formula and its sign convention. So lens formula. Lens formula is very much connected to your mirror formula. So many things will be connected to what we have discussed in the mirror formula. So let's say lens formula is 1 by V minus 1 by U is equivalent to 1 by F, where U, V and F are having their usual meanings. U for object distance, V for image distance, and F is for focal length. Now very first let's start off with the U. U is your object distance, the sign of U is always negative as in case of mirror. So U is always negative because U is again the same side as that of the object, that's why it is always negative. Whereas for V, now V is negative for virtual image this time and positive for your real image. As you can see, for a convex lens, it usually forms the real image. Let's say you have object here, and image is formed on the other side, the real image, right? Because it's a converging mirror. So here, this is your negative side, this is your positive. So every time we have a real image formation, then the sign will be taken as positive. So V is positive for real image and negative for virtual image. Now if you remember for the focal length is same as in case of the mirrors. It is negative for your concave and positive for your convex. So if you talk about the focal length, F is negative for concave and it's positive for convex. Alright, so this is the basic sign convention which you have to remember for your lens formula. U, object distance, which is always negative. V is your image distance, which is positive for your real images and negative for your virtual images. This is vice versa of your mirror. In mirror, we have negative for real. Here we are having negative for virtual, and positive. Their positive was for virtual. Here positive is for real. Then focal length is negative for concave as it was in the case of mirror, and negative for convex as it was in case of the mirror. So focal length is same as spherical mirrors. So we can remember it like same as spherical mirrors. And your U is always negative, and this is vice versa of mirrors. Alright, so these are the basic signs which you have to remember for U, V and F in case of your lens formula. Let's move on and discuss about your next formula, that is the magnification. Now if you remember, in magnification for your mirror was minus V by U. So here magnification is just V by U, which is equivalent to height of image upon height of object. As far as signs are being concerned, they are exactly same as that of the mirror. So M is positive for virtual image, negative for real, greater than 1 for magnified, and less than 1 for diminished. And if the object is same as that of image, then this will be equivalent to 1. So these are the basic signs which you have to remember. Again I am repeating: U, object distance, always negative. V, negative for your virtual images and positive for your real images. Focal length is negative for concave and positive for convex. Magnification formula V by U. In case of your mirrors, we are having minus V by U, but this time it is just V by U for the lens, H dash by H if in terms of the height of the image. Then as far as M is concerned, positive for virtual image, negative for real image, greater than 1 for magnified, less than 1 for diminished, and equivalent to 1 for same size. Okay, now these are the simple sign conventions. Now few tricks which you have to remember while doing the questions, because it is not always there that is mentioned the image is real or virtual. Sometimes the question just uses the keywords. So identifying the keywords, you have to identify whether the image is real or virtual, magnified or diminished, like that. So just see here. Okay, see, if the question use the term real image, if the real image directly being used, then you should know that V has to be positive. Correct? If the question use virtual image term, virtual image, then V has to be negative. And as far as M is concerned, for real image, M is your negative and here M is positive. This is the question is using the term real and virtual. Sometimes the question just use the term the image is obtained on screen. So if image is obtained on screen, then you know from your knowledge that only the real images can be obtained on a screen. So V has to be positive, magnification has to be negative. Now this I am just talking about the lens. Okay, we are not talking about the mirror right now. It is concerned about lens this time. So if the image obtained on the screen, image has to be real, because only real images can be obtained on the screen. So V has need to be positive and needs to be negative. Now if the question says that we are having a lens, such that image is virtual and magnified and focal length is given to you, maybe some x value, x centimeters. Now just seeing this thing, lens, virtual, magnified, focal length, which lens is this? The answer is convex lens. Now you might be thinking how I come to know about this, because only a convex lens can form a virtual magnified image. Concave lens always form virtual diminished image. So in case of vice versa case, that you are given a lens with virtual but diminished image. So if the image is virtual and diminished, the lens has to be x centimeter. It has to be a concave lens. Now how do we convert the concave lens? Because only concave lens can form a diminished virtual image. If by any of the lens the image formed is a real image, then the lens is no doubt a convex lens. So these are the few things which you have to remember while doing the questions. In the upcoming video, we'll be discussing the different types of questions and try to solve them on video, so that it gives you clear idea that how you can apply the lens formula. In the meantime, just go through the sign convention again of both mirror and the lens formula, so that you are able to do the numericals in your upcoming time.